Oh, it's harder to look at than my ex-wife cheating on me.
Did you just get here? Have you taken a look at any of the evidence around?
No, sir, I just got here.
Late and sloppy.
Sloppy? Oh.
What was that?
Burger I ate for lunch today.
Oh, jeez. Well, here. Right there, take a look at this.
What do we got here?
I don't know what it is, but I guess we'll have to take it to forensics to find out for sure.
No can do. Forensics took the day off. Colby was the only one on call, but he called in sick.
Well, I guess we'll just have to do it ourselves then.
What do you mean we do it ourselves? How?
Well, since bodily fluids are organic compounds, we can use FT-IR spectroscopy to figure out exactly what it is.
Okay, sure. But how does it work?
It's elementary.
Fourier transform infrared, or FT-IR, spectroscopy involves the passing of infrared light through a material to measure how much infrared light they absorb. This method is largely similar to a regular IR spectroscopy, where infrared radiation interacts with the sample through particular frequencies that result in molecular bond vibrations. Long story short, FT-IR spectroscopy still uses the same principle of identifying the frequencies at which functional groups vibrate, but is able to differentiate and separate for a broader spectrum of frequencies. There are two mirrors, one stationary and one motile. The motile mirror vibrates at a frequency between 0.1 Hz and 5 Hz, which generates many different wavelengths. These wavelengths can interfere with the wavelengths generated by the molecule. After this, the computer receives the frequency of the absorption, aka the interference of the wavelengths, and displays it on the graph called the interferogram. This is comprised of near uninterpretable raw data. The computer then reinterprets this data into a readable graph called the Fourier transform, which resembles an IR spectroscopy result graph.
Oh, I see. It's better than regular IR spectroscopy because it is able to differentiate between multiple signals simultaneously.
Not bad, kid. You learned fast. Right on cue. Looks like we got our results.
What does it mean?
We've got blood.
And how does it work?
Well,
Bodily fluids are highly important in forensics to identify suspects and victims. Conventional techniques have been used for identification and detection purposes. However, FT-IR technology allows for the detection of a sample of multiple body fluids in one go. FT-IR spectroscopy can distinguish between body fluids based on their unique spectral patterns, combination of peaks, and peak frequencies corresponding to the macromolecule groups common within biological material. Comparisons with known abundant proteins relevant to each body fluid are analyzed to enable specific peaks to be attributed to the relevant protein components. This further reinforced the discrimination and identification of each body fluid. Three major macromolecule groups are observed amongst the body fluids: lipids at about 3,000 centimeters to the minus 1, proteins at about 1,700 and 1,600 centimeters to the minus 1, and at about 1,560, and nucleic acids at about 1,250 centimeters to the minus 1.
it only works on organic compounds. Here, I'll prove it. That's odd. Must be broken.
Something wrong, detective? Man, I love this guy's ex-wife.
Case closed.